Okay, so the next unit that we're going to be moving towards is our Chapter 11 in our textbook. Chapter 11 is Chemical Reactions and Equations. And so we're certainly going to start to get into the details on what happens when when chemical reactions take place and how to look at those equations. We're going to balance equations. We're going to look at the different types of equations. But I want you to understand that first, it's a process where substances combine to make new substances with differing chemical and physical properties. So again, it's that differing chemical and physical properties. You go through physical changes, you rip a sheet of paper in half. Obviously, it's still paper. There's nothing that's changed except for the physical nature of it. Even things like ice melting to water, water evaporating to steam, that's all still H2O. A physical change, a reaction has not taken place. Now, the first thing we should recognize, though, is when we do have a chemical reaction, is that evidence of a chemical reaction. So how do we know that a chemical reaction has taken place? One of the first is the changes of heat. If you have any kind of positive or negative direction in temperature change, you'll see later on that heat and temperature can be used somewhat interchangeably, but also they are different, heat versus temperature. But if you have a change in heat in a positive or negative direction, we'll have evidence. There are two different types of heat. We have endothermic reactions. Endothermic is the absorption of heat. And these make the temperature drop. Or in other words, it feels cold on your hands. And this would be like if you're holding a beaker and the reaction's taking place in there, it's absorbing heat, and so it's feeling cold. Your hand will actually feel cold when, feel cold as you're holding this beaker. An exothermic reaction is a release of heat, and that release of heat, the temperature will rise, or in other words, it feels warm or hot. So you're holding the reaction is taking place in a beaker or whatnot, and because it's releasing heat to surroundings, your hands would feel warm. I do certainly want to show you an example of those, but if I take a look at an endothermic reaction, one that maybe some of our athletes might recognize. This is a cold pack. You know those cold packs, you get a little bruise, you get knocked, and you have a cold pack. Well, it's an exterior with a little baggie. Interior, you have a small bag, that's the one where you pop it and shake it up and it reacts and feels cold. What happens is most of those cold packs have ammonium nitrate or ammonium chloride, but one of the two, probably ammonium, either one of those. And what happens is interior bag is water, and if you bust that, shake it up, then we're going to have a reaction, a connection between those two. I have some ammonium nitrate, and I have a little flask. Oops. And I need to go get some water. Be right back. I thought I was all prepared for that. Just needed to get some water, and certainly I do want to put on my goggles as I do any chemistry. So here I have some water, and I'm going to put some ammonium nitrate in that. Ammonium nitrate. Let's go ahead and take a look at the thermometer and temperature. And I'm reading this water just about room temperature. It's like 21 degrees. 21 degrees. I'm not sure if you're going to be able to see that, but 21 degrees. Now, I'm going to simply go ahead, I'll take this thermometer out, and place some ammonium nitrate in my flask. Give it a little swirl, kind of mix it all up. And take the temperature again. You can't see it too much, but notice that I'm now down to about 18 degrees. Just I put a little bit, so obviously it's not a very strong concentration, but it's gone from 21, 22 degrees to about 18 degrees. So again, that is an endothermic reaction. It's getting cooler, okay? I will show an exothermic as I move along with the next one. So that's change of heat in the negative direction in terms of temperature. Another evidence for chemical reactions is a change in color. Change in color, obviously two things putting together and the color changes. We'll take a look at that in just a minute. Another, formation of precipitate. Precipitate is, in chemistry, a solid. It could be, and I don't want to say a solid always, so it could be a liquid coming out of solution, a solid out of solution. So if you put two liquids together, a solid drops out of it. And you hear the term precipitation for like rain or snow. Obviously we have these gases in the atmosphere and then precipitation, the rain or snow coming out. Let me take a look at an example of this. Again, goggles on. And here I have sodium iodide. Sodium iodide is a clear liquid. Just going to put some clear liquid in this little test tube. A little bit of sodium iodide. And I will put some lead nitrate. Lead nitrate, another clear liquid. And I'm going to place that in my test tube. And you can see, I hope you can see, obviously the color change. We can see the bright yellow, but I'm going to let this sit for a little while and you'll see that there's also precipitate. It's difficult to see on the screen, but there is a solid particles, kind of little small little pieces of particles that are in here. And if I let this sit for a little while, you'll see it. Another example of that is if we have some silver nitrate. Silver nitrate's another solution that's clear. Just going to put some silver nitrate in a test tube and some hydrochloric acid. Hydrochloric acid. And again, as I drop it, you can really see, I think, I put it a little slower, you can see the change of color, the white, and then the precipitate. And I'll let that sit for a little while as well, and we should be able to see the precipitate start to sink to the bottom. So basically what I just showed you right there was lead nitrate reacting with sodium iodide, produced that yellow color change and a precipitate, and silver nitrate, don't need the parentheses, I might as well just get rid of them here. Silver nitrate and HCl, hydrochloric acid, was that white precipitate, and of course the color change. So these are some evidence of chemical reactions as we go through. Let me just quickly show you now the fourth, formation of a gas. So of course when you form gases, that's bubbles. So I do have another flask. Get those goggles back on. Probably should have just left them on. And I'm going to take some hydrochloric acid again. And place some hydrochloric acid in this Erlenmeyer flask. And what I'm now going to do with this hydrochloric acid is place some zinc. metals, zinc metals in the acid, and really I can touch these pieces with my hand just in the efforts of moving it along. So I've got some acid, put in some zinc, and then hopefully you can kind of see the bubbles being released. Reaction taking place, bubbles formation, examples of a gas being released, and therefore the chemical reaction is taking place. You can probably hear it too. And that reaction that I just put together right there is zinc with HCl, and we form some bubbles. And we'll talk about what the products are as we move along, but that's the examples there. Alrighty. What's important that we also recognize, and I just gave you those, knowing what the reactant is, or reactants, and products. Reactant is what's going in, or what you put together. Product is what's coming out, what's the new stuff. Alright, so we'll just leave it at that for now.